Oh, hello guys. Good evening. My name is Clayton D'Souza, and today I'll be doing my first experiment in data structures and algorithms, part one. So, as you can see on the screen out here is a code for stack programming, and I'll be displaying the operations such as pushing an element, popping the elements, and displaying the elements that are contained in the stack. And I'll also be displaying an application of the stack wherein I'll be taking a particular word and reversing it. Concept is very simple. For the application part, what I'll be doing is, see, for the pushing, as you all know that in order to push an element, I'll be um, pushing it in this way. So if this is my element, if this is my array out here, I'll be pushing it in this manner. Like if top is not equal to see if the top is not full. Okay, now I'll be assigning a top element. What is the top element used for? The top element is basically in order to tell this is the top is like how do I describe it? It's like a pointer. It tells you like where if your stack is full or not. Okay, so each time you add an element, you increase top by one. Okay, and each time you remove an element, you decrease top by one. And as you can see, that's what's happening out here. So they're increasing top, and then they're assigning that top position to the new variable. And this is if the top is not equal to the uh, that stack of the size which you have given minus one. So like if so suppose this is your size of the stack, okay, and this is where you start adding second element, you start adding third element, and here if you want to add the fourth element and you have entered the capacity as 4 already, so it will check whether you're on position number 3. So if you're on position number 3, then it will not allow you to add further elements to the stack. And that's what the message has been throwing over here. The stack is full. Similarly, I'll also be doing this for the pop. And pop, I'll be saying the stack is empty if top is equal to minus one. That means top has not incremented itself at all. Okay. So in order to check this, I've already assigned top is equals to minus one in the constructor out here. Okay. So in the display part, yeah, I'll be just displaying my stack, all the elements in the stack using a for loop. And okay, now in the main function, what I've done is I've made like a menu-based, user-friendly based menu, wherein you can enter one for push, two for pop, three for display, four for exit. And yeah, so default statement is, suppose if I enter a number like 5 or 6, it will tell you to enter your correct option. And then if the choice is not the choice is equal to 4, then it will break out here, means it will come out, it will exit. So now what's going to be happening is like I will tell the users to enter a word, okay, in the application part. And in order to take in the word, I'll be um, first taking a variable n and assigning it to the string length of that particular word. Then I'll be making an object of the class stack, and giving it the size as n plus 1, the size of stack which I want. So as you can see over here, the size of stack is assigned to a. And the same thing I've done out here. Just a minute guys, my mouse is a bit oversensitive. Yep, so it's like the same thing I've done over here. I've assigned size of stack as n plus 1. So if n is the string length of the character, suppose n is 5, then LEL will be 6. And why I'm doing that is because so that it can go from 0 to 5. Okay, like 0, 1, 2, 3, 4, 5, 6. If you get it. and for I is equals to 0, I is less than string length of character I plus plus. And now I'll be assigning each variable of that each variable of I'm sorry, each letter of that string to temp. Okay, then uh, using that loop, I'll be pushing temp. So each time, like you'll like suppose there is a word rat, R-A-T. So then over here, I will be 0. So at 0 a position R is there. At one position A is there. At two position T is there. So then I'll be pushing R, pushing A, pushing T. Okay, so the reverse should be TAR, and that's what's happening here. As you can see, if I've put this, I've done this explicit type conversion over here, put a char over here, otherwise I would be getting an integer format of my answer. Sorry, an ASCII value format, my mistake again. Binary value in the ASCII format, whatever you say so. And yep, let's run it. So enter the size of the stack. We'll say 3. Then push, enter the elements of the stack, 1 2 3. Okay, so it has popped out the letter 1 for the instruction number 2. And since okay, so I've entered the instruction in this format, 1 2 3, indicating that 1 was for push. So I pushed the element 1 to the stack. Then 2 was for popping. So I popped out that number, and I popped out 1. And for 3, now since I popped out 1, that means nothing should be there. So it said the stack is empty. So let's do this again for more clear understanding. 1, enter the elements to push to the stack, 1 2. And then let's display the elements in the stack. The elements in the stack is 1. Then let's pop this out. Popped out number 1. Let's display it. Now it says the stack is empty. Let's exit from here and perform the word this thing. Let's enter a word RAT. The reverse is tar. So that, my friends, was stack operation and its implementations. And see you guys in my next video. Thank you.